Here we are going to look at mechanisms used for steering cars or four-wheelers in general. But before we do that, let's understand the condition for correctly steering such a vehicle. At any instant, a turning vehicle has a definite point or an axis about which it is taking a turn, called the center of curvature of that turn. If the axis of a wheel passes through this center, then that particular wheel will be in pure rolling. But if a wheel axis does not pass through this center, then that wheel will be dragged sideways, causing greater wear. So the condition for correct steering is that all the axles of the wheels should meet at the center of curvature. Now let us take a look at this steering mechanism or steering gear called the Davis steering gear. It consists of two fixed pins or revolute pairs which are fixed to the chassis. Then these L-shaped links or the bell crank levers are fitted here. On one side it holds the wheel, on the other side it slides through a guide. These two guides are connected to a third link via two revolute pairs over here, and that link itself is free to slide along this guide. Here is a working model of the arrangement. These are the bell crank levers. So on one side they have the wheel, the other side is sliding through this guide, and these guides are hinged to this link, which is guided again through these supports on the chassis. Let's see it at work. So we are going to steer the car by dragging on this link, so both the wheels take a turn, and you might notice that the angle through which they are turning are not necessarily equal. Now we are going to check whether we have steered the car correctly. That can be done by extending these two lines till they intersect, and we can see this point of intersection is on the rear axle. So we can zoom in and confirm it. It's indeed on the rear axle. So these two axles are meeting at a point, and these two wheels also have their axis meeting at the same point, so the car is correctly steered. But let us check one more position just to make sure that we were not lucky to choose a particular position where it works. So we have one more here, and we will extend them to intersection, and indeed again we get the point of intersection on the rear axle. So the car is getting steered correctly. By symmetry, it will also happen on the other side as well. Unfortunately, this mechanism has its drawbacks, and that is it has too many sliding joints which are going to cause wear, and once the parts have worn out and lost their accuracy, the steering condition may not be met very accurately. So in practice, this is not a very commonly used mechanism. Instead, people use Ackermann's linkage, which we'll see now. This is Ackermann's steering gear. It is essentially a 4-bar mechanism with two bell crank levers like in Davis steering gear, which carry the wheel on one side and a hinge on the other. That hinge is connected to a coupler, and the whole mechanism is fixed to the chassis via these two revolute pairs. Let us see how we can steer this. So I'm going to drag on this link over here. The two wheels turn again through unequal angles like before, and if we find their point of intersection, this time we notice that it is not intersecting on the rear axle. So these two wheels are turning about one point, while these two wheels are turning about an axis which is not coincident with that point, and therefore some of the wheels, or maybe all four, will be dragged to an extent and will rub on the road. So this is not giving us the correct steering. But because all the pairs used here are revolute pairs, which can be well lubricated and which will have lesser wear, makes this more robust, and therefore it is a more commonly used steering mechanism.